So, today we will be talking about computer architecture. Starting from, why does the data path cycle have a huge impact on the performance of the CPU? The data path cycle plays a crucial role in CPU performance because it determines how efficiently the CPU can fetch, process, and store data. Here is why it has a huge impact. Latency and throughput. A long or inefficient data path increases the time it takes to move data between CPU components into brackets, registers, ALU, that's arithmetic logic units, memory, etc., slowing down instruction execution and reducing throughput. The other step, clock speed dependency. The data path cycle length influences the CPU maximum clock speed. A shorter data path allows faster clock cycle, enabling more instruction per second. Pipeline bottlenecks. Modern CPUs use pipeline to process multiple instructions simultaneously. If the data path cycle is poorly optimized, it can create stalls or bottleneck, reducing pipeline efficiency. Energy dependency. Inefficient data paths increase the consumption of the CPU, leading to heat generation and reduced energy efficiency. The data path cycle is the time it takes for the CPU to complete a single operation. This cycle consists of several stages. Fetch. It retrieves an instruction from the memory. Decode. Interpret the instruction and determine what operation to perform. Operate. Execute the instruction, which may involve accessing memory or performing arithmetic operations. Store. Store the results of the operation. In summary, a shorter data path cycle enables the CPU to execute instructions more quickly, leading to significant performance improvement. How does the CPU fetch, decode, and execute instructions? The fetch, decode, execute cycle is the fundamental process through which a CPU operates to execute instructions. Here is a breakdown of each step. 1. Fetch. The CPU retrieves an instruction from the memory. The process involves program counter, that's PC. The PC holds the memory address of the next instruction to execute. Instruction fetch. The instruction stored at the memory address in the PC is copied into the CPU instruction register. Increment PC. The PC is incremented to point to the next instruction in sequence, preparing for the next cycle. Decode. The CPU interprets the fetched instruction to understand what needs to be done. This involves instruction decoder. The fetched binary instruction is analyzed by the CPU instruction on decoder, which breaks it into its components. Opcode. It specifies the operation to perform. Example, add, sub, and load. Operands specify the data or the location of the data. Examples, registers, memory, addresses. So the CPU determines the resources. Example, ALU, that's arithmetic logic unit. Registers required to execute instruction. It carries out the operation specified in the instruction. This process may involve arithmetic logic unit, that's ALU. If the instruction requires mathematical or logical operations to perform the operations. Data movement. If the instruction involves moving data, it will transfer data between memory registers or that's input-output devices. Result storage. The result of the operation is stored in a register or written back memory depending on the instruction. Control unit oversees the fetch, decode, execute cycle, ensuring all components work synchronization. Check cycle. Each step may take one or more clock cycles depending on the CPU architecture. Example. Thank you.